Hello everyone. Let's learn about interrupts today. Imagine your microcontroller is executing a program and suddenly a button is pressed or a timer expires. Should the processor keep executing the program or immediately respond to that event? This is exactly what interrupts allow a processor to do. An interrupt is a signal that temporarily pauses the normal execution of a program so the processor can handle an important event. The code that handles this event is called an interrupt service routine or ISR. ISR or interrupt service routine is a special function that executes automatically when an interrupt occurs. After the ISR finishes, the processor returns to the program that was previously running. Why are interrupts needed? Without interrupts, the processor would need to continuously check whether an event has occurred. This technique is called polling. Polling means repeatedly checking a device in a loop to see whether an event has occurred. Polling wastes processor time, whereas interrupts allow the processor to respond only when an event actually happens. Interrupts can be generated by different peripherals. Peripheral is nothing but a hardware component connected to the processor that performs a specific function. Examples of peripherals that can generate interrupts include timers, UART communication modules, analog to digital converter, external interrupt pins. I think throughout we have used one particular example of interrupt, that is case when a button is pressed. Let me clarify one thing here. Pressing a push button or pressing a button here is an external event. When the button is pressed, it causes change in voltage level, that is either high to low or low to high depending upon the design, at the external interrupt pin of the microcontroller. This voltage change is detected by the interrupt hardware inside the microcontroller, which then generates an interrupt signal internally. This interrupt signal temporarily suspends the current execution of the processor and transfers control to the interrupt service routine. After executing the ISR, the processor resumes the main program from where it was paused. Now let us understand what happens inside the processor during an interrupt. According to the ARM7 architecture used in LPC2148, when an interrupt occurs, the processor performs several steps automatically. The processor first finishes the current instruction, switches to a special exception mode depending on the interrupt type. An exception mode is a special operating mode of the processor used to handle interrupts or other exceptional events, and examples include IRQ mode and FIQ mode. The processor saves the return address in a register called the link register. Link register stores the address that the processor must return to after the interrupt is handled. The processor then saves its current state, that is, the CPSR, which stands for Current Program Status Register, is copied into another register called SPSR. CPSR stores important processor information such as conditional flags and processor mode. In ARM7, that is LPC2148, the mode switch to IRQ or FIQ, updation of link register, saving CPSR to SPSR, all these operations are carried out as one single uninterruptible operation. I have written it as three different steps just for your understanding. The processor then jumps to the vector table entry for that interrupt. A vector table entry is the instruction stored at a specific address that tells the processor where to jump when an exception or interrupt occurs. It usually contains a branch instruction that redirects execution to the actual interrupt handler. From there, execution is redirected to interrupt service routine. Interrupt service routine ends with a special instruction that automatically restores the processor state and returns execution to where it was interrupted.